In this part, we're going to focus on finding excluded values. What I mean by excluded values is finding solutions or numbers that is not in the domain of the function in this rational expression. And if we're trying to find excluded values or numbers solution that is not in domain, we're mainly going to focus on the denominator. So I repeat, mainly going to focus on the denominator. So the rule on finding excluded value is to factor but do not simplify. What I mean by do not simplify, meaning do not cross out your common factors. That's not what I'm asking for. Simply factor and then find your solution. And we'll see what we're going to do once we have our factors in this example. So our first example is x squared minus 81 over x squared minus 13x plus 36. So when we're going to factor the numerator, we notice that it's x squared minus 81. That's a difference of square. So a difference of square, meaning it's going to be 8x plus 9 and x minus 9. Now for the denominator, it's x squared minus 13x plus 36. That's just a general trinomial. When you factor, you're going to get x minus 9 and x minus 4. So here's our numerator, factor out, and here's the denominator, factor out. So again, it says do not simplify. That means I'm not going to cross out my x minus 9, because even though we have one on the top and one on the bottom, again, we're not simplifying. We're just finding excluded value. We need all factors from the denominator. So again, I repeat, we need all factors in the denominator. So what we're going to do next is that we're going to set each factor equal to 0. So when you're finding excluded value, we're going to set each factor equal to 0. So x minus 9 equals 0 and x minus 4 equal to 0. So here I'm going to add 9 to both sides. My first solution is x equals to 9. In the second one, I'm going to add 4 to both sides. And then x equals to 4. So my excluded value, which I'm going to write my answer here. So first I need to state that this is my excluded value. X equal to 9 and x equal to 4. So these are my two answers. This is my final solution. So again, I must state that these are my excluded values. And let me box this up. Now the reason I emphasize that you have to state these are your excluded value, the other process is that if you didn't state it, it ties into what I said before, where you're finding numbers that are not in the domain. So numbers that are not in the domain basically means that I'm going to write my factors from the denominator, x minus 9 not equal to 0 and x minus 4 not equal to 0. So if I'm not going to state that these are my excluded values, then you just simply write your factors from the denominator, x minus 9 not equal to 0, x minus 4 not equal to 0. And the same thing as what we did over here. I'm going to solve for x, so I'm going to add 9 to both sides. So my first solution is x not equal to 9. Over here, I'm going to add 4 to both sides. X not equal to 4. So my final answer is x not equal to 9 and x not equal to 4. So if you're not going to state excluded value, then you can write your final answer in this form. Now if you are going to state that you're looking for excluded value, then you can write x equal to 9, x equal to 4 because you stated that these are your excluded value, meaning numbers not in the domain. But without, you're just simply saying that x cannot be 9 and x cannot be 4. In this example, we have in the numerator x squared plus 7x minus 30. In the denominator, I have x squared plus 10x multiplying to x squared minus 6x plus 9. So let's factor the numerator first. So when you factor, x squared plus 7x minus 30 is a general trinomial. We're going to get x plus 10 times x minus 3. Alright, so let's take a look at the first factor here, first group, x squared plus 10x. The only thing we could do here is GCF. The only thing that's in common between these two terms is x. So I'm going to factor out the x. And then when I do that, what I have left is x plus 10. Now over here, we have x squared minus 6x plus 9. This is a perfect square. So when you factor out this perfect square, I'm going to have x minus 3 times x minus 3. So in this example, in our denominator, we have 4 factors. 1, 2, 3, 4. That's the total amount of factors we have. So again, the rule is factor but do not simplify, meaning I'm not going to cross out the x plus 10 from the numerator and denominator, and I'm not going to cross out x minus 3 from the numerator and denominator. I'm just going to leave this as b. Next is we're going to set our factors equal to 0. So again, I'm looking for my excluded values. Therefore, I'm going to set each factor equal to 0. So the first one, x, set it equal to 0. The second one, x plus 10 equal to 0. Now since I have 2 of the same factor, x minus 3, I'm just going to write it once. So x minus 3 equal to 0. There's no need to write the same work twice because you're going to get the same answer for x minus 3. Alright, so again, even though we have a total amount of 4 factors in the denominator, I wrote 3 out. X equal to 0, x plus 10 equal to 0, and x minus 3 equal to 0. Because for x minus 3, again, you're going to get the same answer if you do this twice. Now for the first one, x equal to 0, there's nothing you do. That's it. Let's take a look at the second one. X plus 10 equal to 0. I'm going to subtract 10 on both sides. So x equal to negative 10. On the last one, x minus 3, I'm going to add 3 to both sides. So x equal to 3. So for my excluded values, you must state it if you having them equal to 0. Excluded values, x equal to 0, x equal to negative 10, and then x equal to 3. So I stated that I'm looking for my excluded values. So x equal to 0, x equal to negative 10, and x equal to 3. Let me box this up. Now, if you were not going to state that you were looking for your excluded value, so just like before, you can say x cannot equal to 0, x plus 10 cannot equal to 0, and x minus 3 cannot equal to 0. So again, if you're not going to state that these are your excluded value, then you can write it as x not equal to 0, x plus 10 not equal to 0, and x minus 3 not equal to 0. And then just solve for x. So here, minus 10 on both sides. So x not equal to negative 10. Over here, plus 3. So x not equal to 3. So my final answer is x not equal to 0, x not equal to negative 10, and x not equal to 3. So those are our final answer. Let me box that up. And here's our final solution. So if you state excluded values, then x can equal to 0, x can equal to negative 10, and x can equal to 3. Because you're stating that these are your excluded values, not in the domain. But if you're not going to state that these are your excluded value, then you must state x cannot be 0, x cannot be negative 10, and x cannot be 3 within the domain.